Hello, my name is Aaron Morris, and I am the CEO and co-founder of Allvision IO. Allvision is a Pittsburgh-based tech startup that makes 3D high-definition maps of urban, road, and rail infrastructure. Our maps and databases are used in a variety of applications. Applications such as urban road and rail asset inventory, curb management, and 4D geospatial analysis. Our core expertise mixes robotics and AI with CAD, GIS, and geospatial mapping. We have a number of partnerships with scanning and data collection service providers, and we work directly with cities, DOTs, rail companies, and AEC firms. The problem that we address is simple. GIS asset databases and HD maps are expensive, time-consuming, and tedious to make and keep maintained. The problem is what's coming, and I'm talking smart cities, 5G, autonomous vehicles, and streamlined delivery systems and services. With these new technologies, the existing databases and ways in which these things are maintained just will not do. Allvision employs robotic sensing technology and deep learning on big data to make immersive virtual worlds that are searchable, recent, and fully accessible. The type of data our platform consumes is common for most of those familiar with mobile mapping vehicles. The three key data sources that we use include geospatial LiDAR point clouds, calibrated 360 panoramic imagery, and vehicle trajectory information. With these basic inputs and our library of classifiers, we can locate and assess a wide range of asset types. Our platform is made accessible in three offerings. We call the first Beacon, the second Park View, and the third Virtual Rail Inspector, or VRI. Joining me now is Ryan Frenz, Head of Engineering, to walk you through these offerings.
Thank you, Aaron. Welcome to Beacon. Beacon's database can be searched by address, point of interest, or coordinate. Here we see an area of interest in Old Town Alexandria, Virginia. By default, you'll see the areas which contain viewable image and LiDAR data, along with all of the assets added by Beacon. The assets are organized by category and type, and the user can create filters to customize the view. Clicking on an asset pin shows high-level info about it, along with 360-degree imagery from the street. Here we see an extracted traffic signal, one of many at this intersection. Here I've created a filter to view fire hydrants, which are a critical asset in building curb and parking maps. And here we have a look at extracted traffic signs. At any time, the user can choose to inspect an asset and enter the data stream in which it was last observed. At this point, the full stream is prepared for streaming to the browser. By default, the user will be immersed in 360-degree panoramic imagery taken from the street. The map remains, but is now populated with deeper information about the data stream, including the route of the sensor and the specific assets extracted in the stream. The imagery provides access to lower-level asset data as extracted from this data stream. The user can edit the asset to annotate it with details as needed, for example, to add condition details or notes to this traffic sign. Extracted poles can be annotated with information about their attachments, usage, and other metadata. Within each image, Beacon shows the location of other nearby images that can be viewed. The user can navigate to another image by selecting one of these markers. The user can also choose to seek forward or backward in the data stream to move faster through the data. And of course, the user can choose to view and interact with any LiDAR information captured by the sensor. Clicking the LiDAR tab moves to this view and begins to stream high-resolution point cloud data to the browser. The LiDAR view can be navigated in the same way as the images and also provides a full 3D navigation experience. Beacon also provides a lightweight toolset for extracting and annotating the dataset. Here we use a simple 3D measurement tool to extract dimensions of this building facade, along with the width of the sidewalk. Other tools allow for manual extraction of key points and assets. For example, we can label this public bench and tag it as furniture. These tags can be used to filter and search the dataset later. All Beacon assets, including user-created ones, can be exported to industry-standard formats or accessed via our API. We can also review the data by playing back the raw LiDAR streams themselves. Here we move through the streaming dataset at the path and velocity of the original sensor. We can also see this data overlaid on the map. Here we expand to make the map our main view and enable LiDAR mode. This mode overlays the LiDAR data on the satellite map, providing additional context about the area captured. These overlays will follow the camera as the user moves through the area of interest. Now that we've seen how to view and interact with data in Beacon, let's look at some specific workflows. Here we have a county scale traffic sign inventory. As the map is moved to the area of interest, the Beacon app uses the Allvision API to stream asset information directly to the browser. By default, the map shows areas containing data streams as well as pins representing asset information extracted from them. Asset pins can be filtered by type to customize the display. Selecting a pin shows all available information about the asset, including coordinates, date observed, and nearby panoramic images. When the user chooses to inspect an asset, Beacon will stream the most recent data around the asset into the browser. From the raw data stream, the asset can be inspected with full surrounding context. From here, the asset can be annotated to add or update project-specific details. Here we see the annotation view for traffic signs. The left pane shows both image and LiDAR views of the asset. The right pane contains various attributes of the sign structure itself, including structural properties and clearances to the roadway. Finally, each sign on the structure is attributed with federal or local designation and panel size. Beacon can compute sign sizes, or users have access to nominal catalogs. Large-scale asset inventories can be efficiently reviewed using Beacon's data navigation tools. Panoramic images can be navigated via on-street markers or seeking forward and back. LiDAR streams can be navigated similarly, as well as played back to recreate the vehicle sensor capture, or navigated in free 3D mode. Now let's look at how Beacon can accelerate auditing of asset inventories. Beacon can accelerate auditing of existing asset inventories and track changes over time. Here we see a section of rail in the Midwest. By default, Beacon will extract and store most safety-critical rail assets. The map will show all available raw data along with all extracted assets. Assets can be filtered by type to customize this view. Selecting an asset pin will show available information about it along with nearby imagery. When the user has an existing inventory or database, this information can be uploaded to Beacon and added to the map. Here we see a GeoJSON layer containing safety-critical signals. Each layer is assigned a color, and assets in the layer appear in that color on the map. External layers can be viewed in the same way. Selecting a pin on the map shows all available info about the asset, including all properties imported and the most recent imagery available. The virtual rail inspector system creates reports showing the differences between external layers and the assets extracted by Beacon. These reports appear as sublayers and are organized by date. Activating a layer changes the map to show the report records. A record is created whenever a discrepancy is found in the two datasets. Results are summarized in the left pane when a report is active. The user can choose to view one or all record types and can use the filters to find large discrepancies or outliers. Clicking on a matched asset pin enters the inspection view. Here we see information about each asset compared, including all properties from the external layer, as well as coordinates and latest observation date from Beacon. On the map, Beacon displays both asset positions and the delta computed. For rail applications, Beacon is configured to compute a linear displacement along the track. All reports created by the VRI system can be inspected in this way. And of course, the reports and all their underlying data can be exported to industry standard formats or accessed via API. And as always, the core features of Beacon help to accelerate visual inspection. Here we choose to inspect an asset, loading the full data stream associated with it into the browser. Here Beacon shows the latest full resolution images and LiDAR data associated with the area and asset of interest. Images can be navigated via the on-track markers. LiDAR can be freely navigated in 3D or played back to revisit the capture itself. Through ParkView, Allvision provides data and analytics that help cities understand what's happening at their curb. By default, the map will show all available curb data. The map can be searched by address or point of interest. Here we see data in downtown Grand Rapids, Michigan. To view detailed curb data, the user selects one or a group of blocks. Here we see a detailed parking inventory map for this selection of blocks. The map is color-coded by parking rule, which can be adjusted by day of week or time of day. The left pane shows each rule's total length as well as its proportion to the overall inventory. The Occupancy tab shows the density and type of vehicles observed at these curbs over time. The map can be customized to show specific times of day or days of week, as well as by vehicle type, personal, commercial, or motorcycle bicycle. The Violations tab compares these vehicle observations to the base parking map to identify violations. The left pane displays a breakdown of these violations by rule type. Finally, we can select a block to see it in full detail. Here we see occupancy observations and raw imagery from the most recent pass of this block. We can choose any pass available in the system. The left pane will show a breakdown of the occupancy for that specific pass. The upper right corner will show the imagery. The Violations tab will show the observed violations at the same pass. Here we see a no parking zone violation and a curb cut violation. Clicking on one of the violations will move the camera to that position. Here we have a rideshare pickup in a no parking zone. We have an occupied loading zone and another vehicle loading behind it, causing a curb cut violation.
All of our offerings are sold on a per linear mile pricing plan with that varies based upon the type of asset. Typical projects with 1 to 2 assets tend to fall within $100 per mile range, but again, these prices vary depending on the type of asset and the frequency of capture. If you're interested in how Allvision can create or refresh your GIS database, there are many ways to get started. Please go to our website at allvision.io, email us at info@allvision.io, or reach out to me at aaron@allvision.io. With that, I thank you, and we look forward to working with you in the near future.